bigbyte is an international consulting firm specializing on supply chain flow optimizations. With our proven methods and techniques, we implement best industry practices, standard processes, and transform your SAP-driven supply chain into a sustainable, automated, and efficient replenishment and inventory management system. Additionally, and perhaps most important, we coach your planners so that they gain utmost competency in the understanding and decision-making around important supply chain dynamics and the competent use of SAP tools and functions. After a bigbyte transformation, your company will experience lower inventories with higher fill rates, as is proven with the following success story at a large automotive supplier with global reach. The company engaging with the bigbyte transformation is a very large global automotive supplier. They were running on SAP for the past 10 years and had varying success using the software to run their supply chain and inventory holdings. The company manufactures and distributes Motorparts, mufflers, shock absorbers, and struts to the automotive aftermarket and original equipment. 90% of the products are manufactured in company-owned plants and 10% are acquired from external suppliers. The initial transformation was focused on 2 primary distribution centers in Europe and a large Eastern European manufacturing plant. The baseline inventory holdings in the DC revolved around 50 million euros with a service level or fill rate quite significantly below 90%. Therefore, the planners and manufacturing personnel were under significant pressure to improve. With our transformation, we were piloting a value stream reaching from external and internal suppliers through distribution centers to customers throughout Europe. Its main focus lasted on the products and their associated fill rates held in the distribution centers for improved customer service with lower capital investment in inventory. Once we implemented effective planning policies in the DCs and therefore streamlined the demand to the suppliers, we shifted our attention to the internal suppliers, the manufacturing plant, and improved the flow of information and material. A third aspect then was provided by the focus on optimal replenishment and inventory holdings of purchased parts for an uninterrupted execution of the production schedule. The company implemented SAP software many years ago. As can be seen in many similar organizations, once the basic functions were implemented, not much in the way of further exploration was done. The initial setup was never questioned, and MRP type PD in combination with some basic lot size procedures and a static safety stock prevailed and dictated the planning process. This practice of deterministic planning, attempting to bring in exactly what we think we will need, in exactly the quantity we think we need it, at exactly the time we think we need it, never works out. Instead, an exorbitant amount of noise is artificially introduced into the supply chain. Additionally to the inherent variability in today's complex value streams. And noise is the number one enemy, as it degrades fill rates and demands large inventory holdings in order to provide high customer service. If a company is primarily focused on forecast accuracy, then the entire organization is fixated on meeting exactly what is predicted but never materializes. Without buffers absorbing the difference between what was predicted and what is actually materializing, every planning system fails miserably, as each underconsumption results in excessive inventory and every overconsumption results in a stockout. Add to that the fatal misconception that a static safety stock will not buffer that noise, and you have a disaster in the making. Also, when the system doesn't work for you, you must devise workarounds and quick fixes. Frustrated planners do just that. They develop their own system. In this case, as in so many others, they made extensive use of Excel spreadsheets. Standardization was out the window, as every planner was not only using their own sheets, but also had a different thinking process assigned to their efforts of balancing demand and supply. Confusing decisions, a lack of valid information, and excess inventory combined with low fill rates was the result. One of the biggest problems was caused by the fact that there was no specific planning concept in use. Planners had a different idea about what to do when things weren't working out as anticipated, or had no idea what to do to cure the inefficiencies. Some disastrous mental models were persistently interfering with flow and caused disruptions on an ongoing basis. Inventories kept creeping up to disastrous levels, binding incredible amounts of capital. Even worse, those excessive inventory levels did nothing to help with the ever-increasing stockouts and degrading fill rates. Planners felt frustrated as they were lacking tools and knowledge to remedy the situations. Suppliers, internally as well as externally, were blamed, and executives lost patience. Of course, the loudest complaint was about the tool. SAP doesn't work for us. Let's buy another tool. Let's hire internal and external consultants to fix this. Let's get a new supply base. Let's outsource inventory management in the DC. Ideas plentiful, but none of these ideas address the source of the problem. There wasn't any concept of a rule-based, standardized, exception-minded planning process which could sustainably optimize inventory holdings with high fill rates. What we suggested was to implement a better way of thinking about planning, putting forward the rules, and instill the exception-minded business. All executable with the system we already owned and the resources we had. All that was needed was some coaching and buffer management and a few tools to automate and standardize the approach. No outsourcing, no firing of people, no new system necessary. As a summary, there were a number of inefficiencies observed. Some relate to the suboptimal system setup with inconsistent master data. Some relate to a lack of the appropriate tool. And most relate to a lack of direction, misunderstanding of supply chain dynamics, and unproductive and disorganized planning parameters. The purpose of the transformation put its main focus on raising the competency level in supply chain planning, implementing and correctly using effective tools, and to organize and fix master data issues. But beside the systemic issues, there were a number of, sometimes hidden, problems that needed different remedies than fixing master data or installing new tools. The communication between the DC's inventory planners and the production schedulers in the manufacturing plant had broken down, and the blame game was rampant. After years of receiving variable and constantly changing demand, the manufacturing plant started focusing on resource utilization. The entire production program was put together under one decisive goal: achieve the highest utilization of resources, machines, and workers possible. With that aim, the plant produced completely independent of what the DC and eventually the customer needed. Produced product was shipped to the DC as soon as it came from the line, and the DC was flooded with product they didn't need. At the same time, the DC experienced stockouts on a frequent basis, and the fill rates degraded. Consequently, there was confusion about who or what was to blame for the ensuing chaos. Everybody planned on their own ability, but nothing was connected or coordinated. Excuses ranged from blaming the SAP system, a lack of effective tools, through to calling out planners and schedulers for a lack of competence or abilities. Primarily, however, the main responsibility was laid upon the suppliers, externally but also internally. After miscoordination, bad results, and constant rescheduling came chaos. There were different lists of priorities. Planners were told that they didn't know what they were doing, but the planners insisted they were doing as told. Replenishment plans were changing every day. The factory didn't build what they were told to. But if the factory was building what they were told, then they had missing purchase parts, and they ended up with lots of unfinished work in process, which was holding up flow. Spreadsheets showed up everywhere, and the SAP system was only used to get the finances updated. Everybody worked themselves outside of SAP, and planners had the feeling they were working for the system instead of the system working for them. Things weren't pleasant, and the dissatisfaction was rampant. Something had to be done. The bigbyte methodology focuses more on the source of the problem, not on a quick fix. In our experience, there are often misunderstandings about the way people plan. Let's have a look. Basically speaking, the process of planning is a forward-looking activity, conjecturing what will happen in the future. The first order of planning is guessing a demand pattern that provides us with anticipated sales figures saved in form of quantities per period. Most people who undertake the task of planning demand feel the need to be as accurate as possible and therefore invest a tremendous amount of time and effort working on forecast accuracy. The resulting pattern may then look something like this. Quantities are plotted per period, and the anticipated numbers are as close as possible to what we hope is going to happen in every period. Note that because we are trying to be as accurate as possible, we'll end up with slightly or majorly different forecast quantities from period to period. Once we think we know what our demand pattern is, we then run a mostly system-supported balancing act and generating supply to cover that anticipated demand. Most planning systems are set up to add a safety stock so that the supply is slightly higher than the anticipated demand. This is supposed to protect against variability, but most often results in dead stock. It all depends how that safety stock is set up and behaves. The most common safety being used to protect against stockouts is the static safety stock. This type of protection is, as its name implies, static and does not partake in the planning process of the future. For example, if you maintain a static safety stock in the MRP2 screen of SAP's Material Master record, then the amount of safety stock does not participate in the planning process, as it's immediately subtracted from the available quantity that is used for planning. From then on out, into the future, the quantity in safety stock is simply ignored, and it is invisible to the MRP run. This has a number of disadvantages, but the biggest problem is that this additional inventory does absolutely nothing to absorb noise or keep a level and steady supply. As you can see in the graphic, the supply, the orders we send to our internal or external suppliers, is uneven to begin with. If the demand changes over time and the system keeps adjusting supply to changing demand, then our suppliers go through bullwhip hell and see themselves in an ever-changing world of exaggerated variability, uncertainty, complexity, and ambiguity, the VUCA world. Like Gartner's, the APICS definition seems to also put major focus on forecast accuracy, as becomes visible in numbers 3, 4, 5, and 7. Nothing wrong with that, I am not at all saying that a forecast should be inaccurate. However, behind these definitions, I do not see any kind of thinking geared towards sending regular and even supply to our suppliers. Why is that so important? Because what is a perfect plan good for if your suppliers, internal or external to your company, fail to deliver material to that plan? If your suppliers fail to deliver reliably, you will miserably fail to execute on that plan. Production orders get stuck on the lines, capacity is wasted, WIP builds up, inventory for the wrong orders build up, lead times explode, and service to your customers fail. All just because you didn't get your stuff in on time. So there must be a better way. A better way than chasing a forecast that is always wrong. Chasing it, adjusting it, readjusting it until it's perfect. But is it really? By the time we get the forecast to perfection, isn't it too late? And by the way, this way of acting is not planning. Rather, it's waiting until we know and then reacting, firefighting, expediting. And if what you're doing is not producing the results you're expecting, then it is time to do something different. A different way of planning could be to avoid the adjustment of the supply and absorb the changes in a cushion before the transfer into the supply. Think of it like a shock absorber in your car. When you ride through a pothole, you don't want to feel the shock. That is why cars have shock absorbers. They absorb the shock at the source before it's transmitted further. What we are doing to deterministic traditional planning is the opposite. We are letting the shock waves all the way through, from customer all the way to supplier. And as they travel through the supply chain, they amplify and end up as the bullwhip effect. So let's address the problem at the source and buffer the demand. We might also have to change the way we look at things. Take, for example, demand. Planners who are after forecast accuracy often end up with a planned demand that looks like what you are seeing here. A demand pattern that is different from period to period introduces unnecessary variability right from the start. What benefit are we getting out of such a thing? We will not hit the exact demand pattern anyway. If we work with uneven demand from the beginning, the unevenness or variability will get worse as we go upstream in the supply chain, and eventually our suppliers experience it much worse. So why not calculating an average? Why not evening out the demand? Why not looking at things in a different way? What you see here could be a different way of demand planning. We're turning things around and smooth out the unevenness in buffers. This will convey an even demand pattern up the supply chain. The variability will result in sometimes a little more inventory, sometimes a little less inventory. An exceptional demand will cause the generation of exception messages. Give it a try, have a different look at demand, and plan differently to balance supply and demand. Your vendors will thank you for it, and you will be rewarded with a much more reliable inflow of goods from your internal and external suppliers. Why should we do this, you might ask? The ultimate purpose of the shock absorber is that we intend to send regular, frequent, and steady demand to our suppliers, internal or external. If we enable our suppliers with even demand, they will deliver more reliably with shorter lead times, and we receive an even inflow of product with which we gain much better control over our inventory holdings. So what we needed to establish with the transformation was a new way of doing business. We want to change how a planner looks at the task of planning itself, how they treat exceptional situations, and how they let the system work with the rules. We want to get away from reactive planning, proactively preparing the organization for future sales and consumption without knowing exactly what will materialize. We can only do that by guessing. But an informed, intuitive guess will produce much better results than trying to be exactly right all the time and turning out to be wrong almost all the time. You've got to plan for something. You don't know if you're 100% right, but if you're 80% right and buffer the rest, you will have a much better situation as if you're 90% right, but have no contingency to fall back on. It's better to be approximately right than precisely wrong. Rather than trying to plan the exact quantity I think I need at the exact time I think I need it for the exact place I think I need it, we can plan for approximate inventory levels and add a little more for just in case. Other than most people think, this type of planning actually reduces the inventory levels instead of increasing it, all due to the fact that we absorb lead times, reduce delays, and proactively anticipate variability. But to make such a system work, you must have rules. Rules which take the human emotionally aspect out of planning. If every planner has to make new decisions every time they have an exceptional situation, they will come up with many different actions every time they face a problem. Rules take noise out of the system too. They normalize and standardize behavior, and they introduce an orderly scientific approach into the planning process. Instead of shooting from the hip, make spur-of-the-moment decision, or being emotional, set down effective rules and make them acceptable throughout your organization. We also must solve problems in a way which remedies the issue holistically and sustainably. To continually apply quick fixes causes unintentional consequences to pop up and afford us to create one workaround after another. Think about the deeper causes of an issue and work on the system to fine-tune policy and grab the problem by the root. This will result in more predictable outcomes that greatly improve performance. We also want to promote a more collaborative working environment, internal as well as externally. We must see our suppliers as partners rather than competitors. It is way too easy to blame them when we have a stock out, but often the supplier is unable to plan anything with the irregular demand we're placing on them. And so we may have to change our ways. Changing is hard, but if what we do doesn't result in better outcomes, we must try something different. It is not guaranteed that if we change, that then things will automatically get better. However, if we do not change at all, then nothing will get better. Putting the transformation together requires multi-pronged approach of continuously and sustainably optimizing people, processes, and systems or tools. The underlying objectives of any optimization are to design functioning processes at the edge of your performance boundaries, to build intuition by getting people to understand the dynamics of your organizational structures, and to use appropriate systems and tools to provide automation and to support the user in their daily work routines. When process, people, and systems come together, we are setting the stage for a successful system of effective materials and products planning. We can then set up the 4 pillars and implement our methodology to let the magic happen. We also needed to change where the planners focused their efforts. We needed them to move away from working for the system. Of course, that was easier said than done, but a concerted focus geared towards managing by exception, keeping master data clean and consistent, moving away from Excel spreadsheets, and replacing those tasks with tools inherent and native to SAP provided the needed motivation. The key to the transformation in thinking and working was that we got the planners to work on the system instead of in the system. What that means is that we had them setting policy rather than applying a quick fix. They were thinking ahead instead of firefighting after the problem occurred. And, maybe most importantly, we had them anticipate future variability and place buffers accordingly, instead of trying to forecast as accurately as possible and then miserably failing to meet actual demand. If I may summarize the success of the transformation, I am very convinced that the change in thinking about planning was the most critical success factor. To start the transformation, we proposed a phased approach. In it, we had to focus on the exception-minded business and start instilling a rule-based system of replenishment and inventory control. We also had to be careful to provide the planners with the automation they needed. Would we miss to provide the tool set, the planners would be overwhelmed and demotivated with the task at hand, and the transformation would fail. And so we suggested to start in a pilot plant. The pilot was actually comprised of a main distribution center, which was supplied by a manufacturing plant and outside vendors. First, we put the rule set, the policy playbook, together. It contained a decision tree and all the policies needed to effectively manage replenishment for a portfolio of 39,000 products. Then we had to do some coaching. Standardization of the process of replenishment was key. We had to raise the competency level of the planners. Competence in planning, competence in decision-making, competence in dealing with the tool set, namely SAP and the SAP add-on tools. We had to be careful to convince the planner of letting go of the old habits and acquiring new ones. Not an easy task, but one that can be accomplished when the methods are enlightening, consistent, and deliver the expected result. Especially important is getting the planners to think about reducing the noise in the supply chain. More often than not, we introduce more noise into the supply chain than what we take out. Inefficient replenishment policies, the use of static safety stocks, lack of proactive planning, and constant expediting all contribute to noise. Add to that the natural variability in supply and demand, and you end up with an ever-moving supply plan, which is impossible to manage. Therefore, we put lots of focus on noise reduction efforts and kept hitting home that noise is our greatest enemy. Of course, we had to supply a set of noise reducing measures, but that is part of our methodology. Eventually, we generated automation and standardization using the exceptionally effective SAP add-on tools. This helped us convince the planners that the system can work for them instead of them working for the system. Let's have a look at what the SAP add-on tools can do. Created by SAP to help customers enhance their SAP experience, these tools put your planning process on steroids. They allow for mass maintenance of master data or policy. They provide a monitoring hub for vast amounts of KPIs. They speed up processing of information, and they provide planners with all the information they need to make good and quick decisions. The SAP add-on tools enable an optimized planning process, coping with all the demands a modern supply chain poses. All of that within standard SAP in order to manage inventories. 4 add-on tools provide the basis of an efficient and automated operating model. The MRP Monitor, with its ability to classify, mass update master data and analytics. The Reorder point and safety stock simulator. This tool allows for buffer sizing and the simulation of service levels. Then there is the MRP Exception Monitor, which provides us with many options to monitor exceptions, set alerts, build and follow rules, and quickly detect possible future missing part situations. The inventory controlling cockpit rounds out the tool set. It's an excellent reporting engine to view and monitor countless inventory KPIs. In particular, the MRP Monitor offers 3 major functions. For one, it executes a classification or segmentation into up to 9 dimensions. ABC for consumption contribution, XYC for consumption consistency, EFG for lead time, UVW for price, HIJ to separate fast movers from the slow movers, etc., etc. Second, the MRP Monitor allows for mass updates of policy. And third, with it you can sort, filter, search for, list, and generally organize your entire portfolio. The MRP Monitor features 4 windows. In its results screen, on the upper left, you get an overview and specifics about the portfolio. The middle screen shows the various segments, and the window on the right provides you with a graphical representation of whatever was selected in the segment screen. The bottom window is your working list. In it, you'll get all the materials you select for master data or policy update. The layout is completely configurable and can be customized for your liking. You may also branch into any transaction you desire without leaving the cockpit. The policy update of the MRP Monitor is supported by a rule table. In the rule table, the policies are stored, and when the planner selects materials for an update, the rule table's conditions can pick up the appropriate rule to be applied. After a quick check, the planner can trigger the policy update for hundreds, if not thousands, of materials in a controlled fashion. The MRP Monitor therefore serves as an indispensable tool in materials planning. Without it, it's hardly possible to keep control over your portfolios. The Reorder Point and Safety Stock Simulator may be called up by its own transaction code, or you may enter it from the MRP Monitor with a selected list of materials. Using the Safety Stock Simulator, buffer levels can be determined, service levels simulated, and future buffer or safety stock cost can be calculated for decision making. A very important feature of the Reorder Point and Safety Stock Simulator is the calculation of reorder points and safety stock with a specific service level. The reorder point and safety stocks can then be mass updated for a whole portfolio of materials controlled by the replenishment type. Another SAP add-on tool is the Exception Monitor. As the name implies, it provides a platform to monitor, manage, and cure exceptional situations. With it, you may find outdated elements, pay attention to critical documents, and attend to potential missing parts. The Exception Monitor has 4 different screens. The first screen is the overview screen. You will get an overview per MRP controller. The list shows critical documents, delayed purchase orders, unconfirmed sales orders, or critical inventory situations, to just name a few. Clicking on a number of the critical documents opens a window with more detail. After selecting an MRP controller's row and pressing the button Material View, you get a list with vast information. The list contains information from the material master. It shows future inventory holdings, quantities, and values for planned receipts, fixed receipts, planned demand, fixed demand, ranges of coverage, and much, much more. Going to the third screen, the Days of Supply View, enables us to view an interesting grid. In it, we can see critically low coverage separated from excessively high coverage. Clicking on the number opens up a more detailed view to analyze. And the last of the 4 screens, the Missing Parts View, provides maybe the most important information for a materials planner to view. Here, you can see a list of all the parts where they are stuck out up on the horizon. You can see the requirements date when the stock out will occur. You can also see the shortage quantity and when the next receipt will cover the shortage. This list provides an excellent view into critical situations ahead of time, so that the planner can still act before it's too late. And finally, the SAP add-on tool Inventory Controlling Cockpit, which is a pure analysis tool with which past inventory behavior may be analyzed graphically and in tables. There are many graphics with which you can get a detailed picture of your inventory movement over time. You may also compare and evaluate various KPIs with each other. The Inventory Controlling Cockpit also allows for the listing of hit lists. Show me the top 10 highest dead stock items, or give me the 10 materials that exhibit the highest average inventory over the past 12 months. And so we engaged in a transformation, using a phased approach, being cognizant of improving people, tools, and processes simultaneously and, of course, effectively. As we all expected, results did not come immediately. Fixed purchase orders and slow-moving inventory were still in the way of fast improvement. However, about 6 weeks after we had set policy on 37,000 parts, inventory started to gradually come down. The new policies asked for more inventory on high movers, and it canceled requests for deliveries on slow movers, so that in sum, demand to the internal and external suppliers still existed, but the system was now asking for the right stuff automatically. What was important was the fact that once the inventory leveled off at the target level, it stayed there. From that point on, the supply base experienced level and regular demand, and therefore they were able to plan themselves. This had the effect that supply came in much more timely and reliably when it was needed. To our great pleasure, at the same time the inventory was coming down, the fill rates didn't just stay. They actually improved by a lot. This was due to the right sizing of the inventory. Unlike many other projects, this transformation wasn't just about an inventory reduction. It was about the implementation of a rule-based system that increased inventory on some parts and reduced inventory on others, so that the company ended up with the right inventory, and all of this sustainably for a long time to come. Adding to all of this, and as mentioned before, the supply base now received level demand. Demand that was even in terms of equal quantities and equal frequencies. On the high-moving parts, we were also sending a forecast to the external suppliers and the manufacturing plant. They used the forecast to plan their own production programs, and therefore were able to deliver more reliably, more accurately, and with much shorter replenishment lead times. Eventually, and most probably the most desirable positive effect, was the development of competent and motivated planners. They are now executing to standard operating procedures. They work according to the exception-minded business, and they make good decisions when things change and the system issues alerts and exceptions. Overall speaking, the planning system was transformed from a highly deterministic management style to one where variability was anticipated and accepted and the plan kept stable through the absorption of noise. When you plan deterministic, trying to foresee what you need and then trying to exactly match that demand, you act like you're trying to herd cats. A futile attempt to control that which is inherently uncontrollable. The deterministic way of planning holds all levels from customer demand through production to purchase parts, replenishment together, and is therefore prone to an immense amount of noise coming into the system every day. Unnecessary noise requires constant rescheduling, which makes it impossible to gain stability in production, replenishment, or customer delivery. The nature of a fixed replenishment proposal, which was calculated to bring in exactly what's needed, exactly when it's needed, must be rescheduled every time there is a change. Therefore, if that is the case, noise has free rein in generating the bullwhip effect and driving long lead times to suppliers and chaotic production and procurement schedules. To avoid the negative effects of deterministic planning was therefore probably the biggest gain of this transformation. And finally, the planners were now given a new tool set. They no longer just only have a hammer. Not all things must look like a nail to them anymore. The SAP system can now work for the planner. They are done having to use Excel spreadsheets to sort and filter, to stay on top of materials and products. All lists now reside inside the same system, and therefore they're always looking at current information that provides them with all they need to make good decisions.
Big Byte.